Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Forge 1.20. And in this tutorial we're going to be covering block entity renderers. So I know it's been a while since I have uploaded a tutorial. However, I just had a lot of uni work recently, so I haven't really been able to get around to it, but we are going to be able to do the block entity renderers today, as that is much needed really in terms of ending the block entity series. So if you're not aware, a block entity renderer is essentially a way to render content inside of your block entity. So say for example, maybe you wanted to render the inventory of your block entity inside of the world, maybe you wanted to render a fluid, maybe you wanted to render something else, then you would do that using a block entity renderer. Consider something like a chest or an enchanting table or anything like that really. So let's get started. So the first thing we are actually going to go ahead and do is come into our client package and in the renderer, and we're going to create a new class, and this will be your block entity renderer. So I'm just going to call this example, and I'm just going to call it a BER, so BER, which is obviously block entity renderer. Just keeps it a little bit simpler. Now I should state that this tutorial will have some prerequisites, so if we go into what I already have, I've already created most of everything we're going to need really, and that is based on the previous tutorials. So kind of the tutorials you will need is obviously the setup tutorial, then you're going to need the block tutorial, the block entity tutorial as well, and then in this case I'm going to be rendering an item, so you would need the inventory tutorial, and then also the synced tutorial, so we are syncing this to the client when the contents change, so you will need that tutorial so you can also update everything correctly to the client. And I believe that, I'm also using a menu and a screen as well, so if you want those as well, then you'll also need to use those tutorials. But apart from that, everything is just as usual, nothing special really. So what we can do is, you see here that I have obviously the inventory, and I've just got a easy method here to go ahead and grab that inventory. So that's what we're going to do inside of our block entity renderer. So first of all, this class needs to implement block entity renderer, and I am just going to turn off Copilot, otherwise it will do this whole tutorial for me, which wouldn't be very good, would it? And this is generic, so this needs to take in our actual block entity class, which is just our example BER block entity is what I called it, which I know doesn't really make any sense, right? Example block entity renderer block entity, but that's just what I've called it, so it doesn't really matter. And then we need to go ahead and implement this method, which will be the render method, and this is basically how it will render everything. So I'm going to put these also on a new line, and then I'm also going to just quickly get rid of these warnings, so I'm going to annotate those as not null. Okay, then we are also going to want a constructor for this, so we're going to want a public example BER, and this will take in a block entity renderer provider dot context, and I'll just call this context. And we're also going to want to make this a field in this class, so we're going to do a private final block entity renderer provider dot context, which will be the context. Now you don't need to set this as a field, however I just like to set it as a field because we have it passed into the constructor anyways, so we might as well use it if we are going to need it. And then you have, as I say, your render method. So this has a bunch of things in here that you can already use. So you see that you have access to your block entity. You have access to the partial ticks, which is effectively the time that you are at between the previous tick and the next tick. So think of this as a number between 0 and 1, where you are between ticks, because the render method will be called every single frame, and as you know, or maybe you don't know, but effectively frames are going to be dependent on your FPS. So for example, if you had 60 FPS, then this method would be called 60 times per second, and the game will tick at 20 times per second. So basically this would give you that where you are between the tick and between the previous tick and the next tick. I'm sure you get it. If not, don't really worry about it, because it's unlikely you're really ever going to need to use that anyways. Then we have the pose stack here, which is effectively what it says. It's a stack of poses, and poses basically refers to a transformation. So think of a scale, a rotation, and a translation. That is a pose, and this is just a stack of poses. So you can push to the stack, and then you can do your transformations, you can render, and then you can pop to the stack, and it will revert back to the original transformation. Then you have the multi-buffer source, which is effectively, well, once again, really what it just says. It's basically a source of buffers, but multiple buffers. So that's really all it is. It just allows you to, for example, draw quads if we wanted to do that, which we'll be talking about that ideally in the next tutorial when we do fluid rendering for a block entity renderer. We will be using this to draw the quads ourselves. We're not going to directly be using this in this tutorial, however we may need to pass it into some methods. Then we have the packed light, which is effectively the combined light at your block entity's position. So think of skylight and like normal light as well. It's basically packed those two together into just one number. And then we have the packed overlay, which is effectively the same thing. I think it's just for like shadows and stuff. Once again, you don't really need to worry about this too much though, because we're only going to be passing this into methods. We're not really going to be dealing with these ourselves. So now we've got all of that out of the way, let's go ahead and actually try and render the item that is stored in our inventory. So I only have one slot, so there's only one item to deal with, so that makes it quite simple for us. So I'm just going to grab an item stack, and I'm going to say pBlockEntity dot get stack, or we have to actually get the inventory first, of course, so we can get the inventory using our method, and then we can call get stack in slot, and since I only have one slot, that's going to be slot 0. Then I'm just going to say if the stack is empty, then I'm just going to go ahead and return, since we don't want to try and render anything if there's no stack even present. Then we're just going to grab the actual level from our block entity. So we can do level is equal pBlockEntity.get level. And I think this is a perfect opportunity to also mention the Minecraft class. So if you are not aware, there is a class called Minecraft, and this is effectively the main class that Minecraft uses. It's not exactly the main class, but it will just call it the main class for the purposes of this. And effectively this is only on the client, so it's very important that if you ever use this class, it's only on the client and you're not referencing it in any classes that could even be loaded on the server, because that wouldn't be very good. So you can say Minecraft is equal Minecraft.getInstance, and that does allow you to get a Minecraft instance. Now from Minecraft you can actually get a bunch of information. So if we do Minecraft dot, you see there are tons of things in here that we could use. However, from this, for example, you can get the player, and you can also get the level. So that is basically the client player, so your local self, and also the client's level. So that's basically the world that is being rendered currently on the client. And then you can also get like the GUI, for example, which would be any currently open GUI. You can get the current font instance, you can get the camera entity, you can get all of these different things. As I say, we're not going to be using that in this tutorial. However, just note that that is there available for you to use if you need to access any of that data. So now that we have the level, we can just once again do that same if check. So if level is null, then we can just return, because we don't want to do anything if there's no level, because we want to be able to render stuff inside of the level. Then we can go ahead and actually get the position. So we can say block pos, and we're going to do pBlockEntity.get block pos. And I'm actually going to get the above position, since we're going to need to get the lighting of the above position, and you'll see why in a moment. So then what we can go ahead and do is we can actually render an item. Now to do that, we can actually use our context right here. So we can do this dot context. We can do get item renderer, and you'll see there's a bunch of different renderers here as well. So you can also get the entity renderer if you wanted to render an entity. You can also get the block renderer if you wanted to use that. But we're going to use the item renderer, and we are going to call the method render static. And you'll see once again there's a few different methods in here. Really, render static is the one you're going to use most of the time. Now, the first parameter that it wants is obviously going to be the item stack. Now, we can just pass in our stack that we created up here. Then what it wants is an item display context, and this is effectively how it should be displayed. So if you recall from our actually, I don't think we covered this in a tutorial yet. However, if you are using, for example, Blockbench, and you're creating, say, an item model or a block model, there will be a display tab on the kind of top right of the screen. Hopefully I will put a screenshot on the screen now, kind of showing you what I mean. And effectively this allows you to change how it will be viewed in different transformations. So for example, in a GUI, or on the ground as like an entity, or on the player's head, or in the main hand, in the offhand, in the first person, in the third person, etc., etc., all these kind of things. So what we can actually do here is choose how we want it to be displayed. So which transformation of those should it use? And we're just going to want fixed in this case, because we just want it to be kind of a normal display so that we can mess around with those transformations ourselves. So we can just give it fixed. Then what it's going to want is basically the packed light. Now, you would think that we could pass in this packed light here. However, we can't do that because this packed light will refer to the actual light of the block itself that our block entity renderer is. Now I'm going to try and render the item on top of our block entity, and so this packed light would always basically be dark because it's inside of our block. Now obviously you could set your block settings to not be opaque, and in which case it would allow through light and you could use this packed light. However, I instead want to actually get the packed light myself and calculate that myself from the position above our block entity. So I'm going to do light texture dot pack. This will first take in the block light. So for example, consider torches, glowstone, etc. So we can do level dot get brightness, and we can pass in the light layer. And we're going to pass in light layer dot block, and then we're just going to pass in that position. And remember, this position is the position above our block entity. Then we're going to need to pass in the skylight, which will be exactly the same thing, except using light layer dot sky. So we're going to pass that in there. Then it's going to want the packed overlay. Now, once again, we could calculate this if we wanted. However, I am instead going to use overlay texture dot no overlay, and that will basically just give us the basic kind of overlay. But obviously if you wanted, you could just use this packed overlay here. It doesn't really matter. Then we're just going to give it the pose stack. Then it's going to want the buffer, so we're going to pass that in as well. Then it's going to want the level, and then it's also going to want a seed. I'm just going to give that 0 since it's not really that important for what we're doing here. And that should basically be it for the renderer. So that should render an item. Now, we could leave it there. However, I want to also show you a few other things that you could do. For example, maybe you wanted to have it rotate in a certain way, or just have some kind of special transformations. So we're going to do a little bit of math and just kind of do some special transformations to it to make it a little bit more exciting. So I'm just going to write a little bit of math here that should do this for us. So first of all, I'm going to calculate an offset that I want it to use. Now, effectively, I just want it to kind of move around, rotate, scale, all those kind of things in like a sine wave, just to keep it nice and simple, really. So I'm just going to do math.sine, and I'm going to pass in the game time first of all. So level.get game time, I believe that is. And then I'm going to add on the partial tick, and that just makes sure it kind of goes at the same rate as it does for everyone. And I'm going to divide that by 10, and then I'm going to divide this whole thing by 6, which kind of just clamps it down a little bit. And then I'm going to do the exact same thing for the rotation and the scale, except using maybe some slightly different values. I've already kind of pre-calculated these values since I obviously prepared for this tutorial beforehand, so you would obviously mess around with this however you wanted in your circumstances, but I'm just going to write these out and I'll be back with you once I've done that. Okay, there we go. So I've just gone ahead and calculated those, so nice and simple really. And then I'm going to actually perform these transformations on this rendered item right here. So how do we do that? Well, as I mentioned, we can use the pose stack. So we're going to create a new pose or a new transformation. So we need to push to the stack, and then we need to perform our transformations. Now I'm going to start by translating. So I'm going to do pposestack.translate. The first one is obviously the X, so I'm going to translate it by 0.5 because I want it to be kind of in the middle. And then I'm going to do 1.3 for the height, so it's kind of above by almost 1.5. And the reason it's almost 1.5 is because I'm then going to add that offset on top. And then I'm going to do 0.5 on the Z, which just once again means it's going to be in the middle. Then I'm going to scale it a little bit, so I'm going to do pposestack.scale, and I'm going to need to cast these two floats, but we can pass in the scale for all three of these. So float scale and then float scale. There we go. And then we can also do any rotations we want as well. So pposestack, and for rotations it's not rotate, it is actually mul pose. And then we can use axis dot, and then you can choose which axis you want to rotate on. So whether that is Y positive, whether it's X negative, whether it's X positive, Y negative, Z positive, etc. I'm going to be using Y positive, and then I'm going to do rotation degrees. You see that you can also use radians if you wanted, but degrees is just easier to work with really. And then I'm going to cast our rotation to a float like that. And then we render it, and then all we need to do is actually pop it. So pposestack.pop pose. Now, before I actually pop it, I also would like to render some text above it, above the item. So let's go ahead and do that. And this text is basically just going to be the stack count of that item. So nice and simple, really. I've missed a bracket there. There we go. So before I pop it, because I want it to use that same transformation, so I'm going to grab the font because I want to render some text. So make sure you obviously select the correct font, which is the Minecraft one, not AWT. So font is equal this.context.get font. Then with the font, we maybe want to just modify this a little bit. So by default, it kind of won't be in the correct transformations. And I already know this obviously because I've already tested it, but we're going to want to scale it down a lot. So we're going to go 0.05, and then we're going to want to go negative 0.05 on the Y, because we need to rotate it round the correct way. And then we also want 0.05 on the Z, which will just scale it down quite a lot. And so negative here will effectively just flip that round, so it's the correct way round. Then we want to go ahead and translate it to, whatever position we want, basically. So obviously these are going to be different depending on what you're doing. So I'm just kind of showing you kind of what I want this to look like, and you'll see in a second. So I'm just going to do a font width of the stacks count plus obviously a string, because we need it to be a string, and then divide by 2. So that will just go ahead and center that how I want it centered. And then I'm going to do negative 15 on the Y, because otherwise it won't be correctly positioned there. So that actually is adding on the Y, you've got to remember, because we've already gone ahead and inversed the scale of it. So that means we have to then negative if we want to go positive. And then we can just draw it however we want. So we can do font.draw in batch, and we can say stack.getCount, and obviously that needs to be a string. Then we can give it the X position. I'm just going to do 0 and 0, but obviously you can calculate those differently if you wish. Then we just have a color, so I'm just going to use a hexadecimal color here, and I've already chosen to do EC. And then as a drop shadow, I'm just going to say false, because I don't want it to give a drop shadow. Then we need to give it the basically a matrix 4F, which is used for the transformation. So what we do to get that is we just do pposestack.last.pose, and that gives us the matrix 4F that it wants. Then it just wants the buffer, so that's just pbuffer. Then it wants the display mode, so you can choose how you want it to display. I just want it to display normally, nothing special really. And then 0. And then we're also going to want the light again. So since I don't really want to recalculate this, I'm going to go ahead and just calculate this up here. And then we won't have to calculate that again. So int packed light is going to be equal to our light texture.pack. And then we can replace that in there. And then we can also use that down here. So this 0 here, by the way, it's just the background color. I'm not sure if I mentioned that. And if we go ahead and end that, that should basically get us where we want. Now you will see that it says very clearly here that this constructor is never used, this class is never used. So we do need to go ahead and actually register this block entity renderer. So let's go into our client package, and in handler I have the client mod handler here. If you don't already have this, then you'll just need to create this class here with this annotation, and you'll need a subscribe event to the register renderers event. So in here, I'm just going to create a new comment for block entities, and then I'm going to do event.register block entity renderer. We first need to give it our block entity type, which will be example BER block entity .get, of course, and then it will need to be the example BER : new, which will just use that constructor that we have right here, and you'll see that is now correctly used. So let's go ahead and let's run the game, and let's go ahead and see what it does. So I will see you inside of the game. Alright, so here I am inside of the game, and let's go ahead and place down our BER. So I'm just going to place it right there, and then I'm going to open it up. I'm going to put my item in there, and you'll see that that renders. And if I look on this side here, you can see that we also have some text rendered above it as well. And obviously, maybe you would want to modify that text. So instead of following the rotation of that, maybe it follows the player. You could do that kind of like a billboard style if you wanted, of course. and obviously I can replace that out with a block, and you'll see that works perfectly fine as well. And yeah, I mean, that's pretty much it really. So I hope you guys found this tutorial useful, and in the next tutorial we'll be covering fluid rendering, so that our fluid block entity right here can actually go ahead and render whatever fluid. And then after that, I believe we are probably going to be doing mix-ins. However, I'm possibly planning to do a tutorial on block entity animations, but using the vanilla animation system, not GeckoLib. So that might be interesting. No one has ever done that before, so that would be kind of a first. I would be the first one to do that. It's really not as hard as it sounds though, so I might do that as kind of a tutorial after the next, or maybe the next one. I guess it depends how I feel. But yeah, so I hope you guys found this useful, and obviously if you did, please do be sure to give it a like and subscribe. And if you have any problems with this tutorial or any other tutorials, feel free to join my Discord server, and the link is in the description down below, and you can get some help there. And if you'd really like to support me to continue making these tutorials, then you can join my Patreon as well, which is also linked down below. And yeah, I will see you guys in the next tutorial. Goodbye.